Solving equations by extraction of roots. Let's first take a review of solving just general equations. To solve this particular equation, 2x equals 16, what it's saying is that 2 times the value of x equals 16. And we want to isolate the x variable. In order to do that, we need to do an equal but opposite operation. So the equal and opposite operation of multiplying x by 2 is dividing it by 2. Whatever we do to one side, we got to do to the other side of the equation. These two cancel out to 1, so we're left with a value of x equals 8. Now we get into using the extraction of roots. We'll take a similar example where we have x squared equals 16. What we're looking for again here is the single value of x. Here we have an x squared, and we're squaring the x value. What we need to do is take an equal but opposite operation of squaring a variable. Well, the equal and opposite operation of squaring a variable is simply taking the square root of that variable. Because what happens is whenever we take the square root of a square, they end up canceling one another out, similar to the 2 divided by the 2. But whatever I do to one side, I also have to do to the other side of the equation. So when these two cancel out, what I'm left with is the value of x equals the square root of 16, which comes out to being both a plus and a minus value of 4, meaning I have both the positive value of 4 and the negative value of 4, because the square root of 16 simply means that if I resubstitute this value of 4 into the equation, positive 4 squared does give me a value of 16, but also the negative value is also a true statement. Negative 4 times the negative 4 gives me back a positive 16. So whenever I extract the roots from the square root symbol, I have two possible. I got a positive value and a negative value.